Okay, let's quickly solve this kinematic problem that is asking us to convert this velocity time graph to an acceleration time graph. We'll come back to the second part, but let's deal with this part first. So this is our velocity time graph, and we need to make an acceleration time graph from this. So the first thing that you need to do is draw your graph. Then you extend these points of interest like 5, then we have 15, we have 20. Okay, so here we will have velocity, here you have time. So now how do we convert this? What we need to know is that the gradient for a velocity time graph is the acceleration. So this, what you're seeing, this line, it is the acceleration. The gradient is the acceleration. So what you need to do now, once you've gotten your points of interest like 5, 15, and 20, you need to find the acceleration from 0 seconds to 5 seconds, and from 5 to 15, and from 15 20. So what is the acceleration from 0 to 5 seconds? So we know that our formula goes like V is equal to U plus AT, and we can rewrite this to see to be acceleration is equal to final velocity minus initial velocity over t. So now if we replace our final velocity at t is equal to 5 seconds, here is -8, so -8. Our initial velocity at t is equal to 0. T is equal to 0 is here. It's 2 -8 divided by the time. The time is 5 seconds. What you get is -8 plus 8. This will over 5. This will give you 0. So meaning that the acceleration from 0 to 5 seconds is 0. So what you have here is just a line on the 0 mark. It's 0. What of the acceleration from 5 seconds to 15 seconds? Let's try to find that. So from 5 seconds to 15 seconds, our formula is equal to A V minus U over T. So what is our final velocity at 15 seconds? It's 8. We'll have 8 and negative. What is our initial velocity at 5 seconds? What was the velocity at 5 seconds? The velocity at 5 seconds was -8. So you have -8. Then over, what is the time period? Don't say 15, because we're starting to count the time from 5 to 15. And to find that this duration is just 10 seconds. Don't say 15 seconds, it's 10. So this is going to be equal to 8 plus 8 over 10, which is equal to 16 over 10, which is 1.6 meters per second squared as your acceleration. So we mark a point here, call it 1.6. That is the acceleration from 5 to 15. Another point that you need to take note is that for the most part, acceleration is constant. So the acceleration from the 5 seconds to 15 seconds, it's constant, so meaning it has a straight line on its graph. So we will have a straight line from 5 up to 15. Yes, this is going to be the line, and we're just going to connect it like this. And again, we need to find the acceleration from 15 seconds to 20 seconds. Now that our a is equal to v minus u over t, and this will be equal to, what is the final velocity at 10 seconds, at 20 seconds? We find that it's 8. What is the velocity at 15 seconds? It's still 8. We're dividing by the time period, this time period, which is 5. So over 5, this is going to be equal to 0. Yeah, so the acceleration is equal to 0. The shortcut for this is that where you just see a straight line on the velocity time graph, just know that the acceleration is 0. Just as here we had a straight line, the acceleration was 0. Even here we have a straight line, the acceleration is 0. So we need to go on the 0 mark. Mark it like this, and we just drop this line. So that is your graph for the acceleration time graph. It's going to be like this. Okay, so we have that graph. Now let's move on to the second part of the question, which is saying determine the average acceleration from 5 seconds to 15 seconds and from 0 seconds to 20 seconds. So let me just remove this part since we've already solved for it. Okay, so we're basically just finding the acceleration from 5 to 15 seconds. Now we need to go back to our graph here. We know that acceleration is equal to final velocity minus the initial velocity over t. And the final velocity at 15 seconds, what was the velocity? It's 8. 8 minus, what is the initial velocity at 5 seconds? So our velocity at 5 seconds is -8. So we say -8 over the time period from 5 to 15. It is 10 seconds. This would be 1.6 seconds. Now what about from 0 to 20 seconds? Write our formula. T, this will be equal to, our final velocity is at 20 seconds. Our initial velocity is at 0 seconds. So we say, what is the velocity at 20? It is 8. What is the velocity at 0? Find that it's -8 at 0 seconds. So we divide this by the total time period from 0 to 20. The time period is 20, and this will give you 0.8 meters per second squared. I said second, I'm supposed to say meters per second squared here. Okay, so that would be your answers for B. So that's how you solve this question.